Question number 2. A is the point 3, 7 and B is the point -1, 5. So they have given the coordinates of A and B. Find the coordinates of the midpoint of the line AB. So assume there is a line AB. The endpoints are 3, 7 and -1, 5. So midpoint of AB is just you have to add the coordinates and divide them by 2. So 3 plus -1 by 2, comma 7 plus 5 by 2, which is 2 by 2 and 12 by 2, which gives us 1, 6. So 1 is the x coordinate and 6 is the y coordinate of the midpoint. So this is 1, 6. Second subdivision, write AB as a column vector. They have not given AB directly to us. So we have to first figure out what is AB and then it has to be represented as a column vector. So AB is the distance of this line. So very simple. So take the respective coordinates and subtract end minus start. End minus start. End minus start. So this will give us -4, -2. So write this in the form of a column vector. That's it. Third subdivision. AC is equal to 3 times BA. There's a vector AC which is measuring 3 times BA. In the previous two subdivisions, we have never heard of BA, but we know AB. So BA is nothing but the negative of AB. Direction is getting changed. So AC is equal to 3 times negative AB. AB we know already, which is nothing but -4, -2. So giving away the -2 each one of them, then it becomes 4 and 2. Multiplying that by 3, we get 12 and 6. So this is just AC, but we are supposed to get the coordinates of C, which means we know A, and we know this distance AC, which is written in the vector form. But we need to get the destination C. So we just have to add 3 plus 12. 3 plus 12 and 7 plus 6, which gives us 15 and 13. So the coordinates of C are 15 and 13. Subdivision B. Now there is a graph given to us There's a trapezium sort of a figure P, which is shaded, and I see another small trapezium Q. It looks similar. Q is looking similar to P. So before starting to answer a question, observe the diagram clearly so that you will get an idea of what's there in the graph. I see P, I see Q. Q looks like a similar one of P, but it is small in size. So that's my judgment. Now, the first question says, rotate shape P through 180 degree about the point 4, 1. Okay, so the point has been given to us. So this is the point of rotation. If you want to use a trace paper, you can use it. Or you are very good at visualizing, then you can go ahead without the trace paper even. So let's try to do it without the trace paper. So for that, I have to check which line is convenient for me to go ahead. Suppose I am taking this line. Fine, so I am just visualizing what would happen if I raise it to 90 degree. It would come here. It would come here like this. And then if I make it another 90 degree, so it will go here like this. Done. Then the same way, these two lines, I'm just marking this line, which is running from 1 to 3. Instead, I think I can have the coordinates named instead of telling this and that. B, C, and D. Now I have moved this A, vertex A has come here. So A dash, let me name it as A dash. And then D, it has to come down like this, D dash. And then C dash would come like this. Of course, we have our B dash there itself because that cannot be moved. And then I connect it here to C dash. So after rotating P, I get that P dash. Let me name it as P dash. They were never asked to name it here, but I'm just naming it. So I have rotated this P in 180 degree, right? So the coordinates of this, let me quickly make it. So this is 7, 1, and B dash is again 4, 1. C dash is 5, -1, and D dash is 7, -1. So first question is done. Second subdivision. Reflect P in the line y is equal to x plus 2. So first of all, we have to draw the line. To draw the line, I need to make one small table. So when x is -2, substitute in this equation y is equal to x plus 2. So I will get y as 0. And when x is 0, I'll get 2. When x is 2, I get 4 because it is plus 2. Then, so let's take this, that's it. And maybe x is 4, then y is 6. This is more than enough. We have done many. So let's plot this. -2, 0, 0, 2, 2, it's 4, and 4, it's 6. Now connect them. Right. Okay, so once it is connected, so this is a line of symmetry. Again, here also, if you want to use trace paper, you can use it, or you can go ahead doing it by visualizing yourself. That's it. Now let's project this. We're just asking for the shape P. So two boxes. Then 1, 2, 3 from A to B. 1, 2, 3, three boxes. And this B to C goes diagonally. So reflect shape P in the line y is equal to x plus 2. So let us name this line y is equal to x plus 2. Yeah, and let's name it as P double dash. And they never asked to do that, but I'm just doing it. Fine. So if you are not confident enough, do it with a trace paper. Now the third one, describe fully the single transformation that maps P onto Q. So P onto Q. So as I said, first what I observed was P and Q. Q is looking like a miniature of P. Fine. So how to get that? So again, a small, you can visualize and make a sort of small adjustment so that it sits on this. So let's try doing this. I'll take another color. So I am visualizing as if I'm going to rotate this shape Q, and if I make it sit like this, it's actually like this. Okay, so what has happened? It has got shrunk. P has got shrunk to, to become Q. But let's use the word enlargement. Enlargement by a scale factor of, what could be the scale factor? Now look at the sides. This side, the corresponding sides. P was two boxes, means Q has become one box. So I could see that in all the sides. So enlargement is minus half, because I said it has got shrunk. Instead of using the word shrunk, I am writing it as enlargement, but I'm putting a negative factor.